Imagine for a second, you are just casually scrolling online, minding your own business, and suddenly you're confronted with this video of a 7-foot-tall mechanical centaur.
Yeah, that is a jarring thing to pop up on your feed.
Right. I mean, it has 4 massive legs, this armored torso, and these imposing goat-like horns. And then instead of hands, it's wielding actual chainsaws.
It really just triggers that instinctual primitive part of the brain. You see something like that, and every survival instinct you have screams that you're looking at, an apex predator from some dystopian future.
I honestly thought it was a promotional stunt for a video game when I first saw it. But this machine is very real. It's called the Satyress Threehalves.
And the visceral outrage tearing through the internet right now about it, it's just deafening.
It really is. But looking at the stack of reports we have on this for today's deep dive from URBT News, Fast Company, and Newsweek, the online panic is kind of completely missing the point.
Oh, absolutely. They're entirely focused on the aesthetic.
Exactly. So if you are sitting there wondering how this kind of technology impacts your business, your investments, or, well, just the future of human labor in general, we really need to look past that terrifying exterior.
Because the reality is, this machine is forcing a complete reevaluation of industrial safety, liability, and the economics of physical work.
So let's just jump right in. Why does it look like a demon? I mean, the immediate assumption is that the engineers were trying to be intimidating, right?
Yeah, it feels intentional, but in heavy robotics, form rigorously follows function. So every single frightening aspect of the Satyress Threehalves is actually a solution to a massive engineering hurdle.
Which makes sense. I mean, I look at the recent trend in robotics, and everything is a sleek, bipedal humanoid. Tech companies are just obsessed with building metal versions of humans that walk on 2 legs.
Right, but the Satyress is a quadruped. It's built like a centaur.
And from what I gather in the Fast Company breakdown, that is a direct response to the absolute nightmare of trying to keep a 2-legged robot upright on a chaotic, real-world job site.
Exactly. Balancing a bipedal robot is basically trying to solve an inverted pendulum problem in real time.
An inverted pendulum problem.
Yeah, so a human walking on 2 legs is essentially just catching themselves from falling forward with every single step. For a machine to do that, it requires these continuous microsecond computations just to adjust its center of gravity.
Oh, wow. So it's constantly having to think just to stand up?
Constantly. So if you put a 2-legged robot on a flat laboratory floor, it looks graceful. But put that same robot on a disaster site covered in unstable rubble or, slick with oil, and that bipedal design becomes a massive liability.
Right, whereas a quadruped provides this wide, inherently stable base. 4 legs drastically reduce the computational load required just to keep the machine from falling over.
Which brings up a huge safety issue regarding power. If a bipedal robot is carrying like a 200-pound steel beam and its battery suddenly dies...
This just goes completely limp, right? It collapses.
It collapses.
Yeah.
And that is a terrifying scenario for any human working next to it. That happens because most humanoid robots use active servo motors.
Meaning they need power just to hold their position.
Exactly. An active servo requires a continuous flow of electricity just to stay rigid. The moment power is severed, the resistance drops to 0.
But the Satyress Threehalves approaches this from the exact opposite direction, right? The engineers utilized friction brake joints.
They did. So a friction brake system is default locked. When the electrical current is cut, the brakes mechanically engage.
Oh, so instead of collapsing into a heap of metal, it instantly freezes into like a rigid, unmoving statue.
Precisely. It is this brilliant fail-safe mechanism designed to protect whatever or whoever is standing next to it when things inevitably go wrong.
I mean, that makes total sense, but it still doesn't explain the horns. Or, frankly, the lack of hands. Human hands are the ultimate tools. We built the entire world with them.
They are, but emulating the human hand is arguably the holy grail of robotics. It's also, unfortunately, the most fragile point of failure.
Because of all the tiny moving parts.
Yeah, think about the biomechanics of your own hand. You have this incredibly complex network of tendons, ligaments, and small bones that allow you to, say, crush a soda can or gently pick up an egg.
Right.
Translating that into mechanical actuation requires dozens of tiny, delicate motors and sensors. If you send a robot with delicate mechanical fingers into a mine to operate heavy jackhammers all day,
the vibration and sheer physical load will just shatter those intricate components within hours. It would be like trying to use a luxury Swiss watch as a hammer.
That is the perfect analogy. You are just begging to break the most expensive part of the machine. So Satyress completely abandoned the vanity of human hands.
They went with what Fast Company calls quick connect wrist interfaces, right?
Yes. The robot's forearm acts as a universal adapter and a direct power source. Instead of having a robot clumsily try to grip the handle of a Makita power drill, you literally detach the drill's handle and snap the core mechanism directly into the robot's wrist.
And the arm can route, what was it, 12-volt, 18-volt, or 48-volt electrical power straight into whatever tool you attach, which explains the chainsaw arms in that viral video.
Exactly. It isn't holding a chainsaw, its arm is the chainsaw, and it can swap that out for a heavy-duty rotary hammer 5 minutes later.
It's basically a rugged Swiss Army centaur. And despite how imposing it looks fully deployed at 7 feet tall, it's actually highly modular.
Very modular. The joints are designed to fold into this surprisingly compact footprint. The manufacturer demonstrated that 2 of these units can crouch side by side in the bed of a standard Ford F-150 pickup truck.
That's wild. So you don't even need a massive specialized flatbed trailer to move these things around. A local public works crew can just toss 2 of them in the back of a truck they already own and drive straight to a water main break.
Exactly. That level of practical deployment makes it clear this isn't some experimental prototype meant to live in a lab forever. It's built to go into the mud today.
But if the hardware is ready for the real world, how is it navigating that mud? Because when we look at the brain of this machine, this California-based startup is doing something that seems, frankly, totally counterintuitive to where the rest of Silicon Valley is heading.
Yeah, the entire tech sector right now is locked in this arms race toward fully autonomous artificial intelligence. The prevailing goal is to build robots that can analyze a chaotic environment, make independent decisions, and execute tasks with zero human intervention.
But Satyress is aggressively pivoting away from that. Their entire platform is built on teleoperation.
Meaning there's a human operator holding the reins at all times. The machine literally doesn't make a single critical movement without human input.
The URBT news coverage highlights their official corporate mission statement, which explicitly frames this. They state they are taking a teleoperation-focused approach not to replace skilled workers, but to give skilled workers superpowers.
Which is a very bold claim.
Yep. And I have to push back here because I hear that phrase, giving workers superpowers, and I immediately throw up a red flag. Is that just slick corporate spin?
It definitely sounds like it could be.
Because if I am a construction worker or a welder, my alarm bells are deafening right now. If you give one operator the ability to control a machine that works 3 times as fast and never needs a water break, you don't need the rest of the crew.
Right. You keep the one guy with the superpowers and you hand out pink slips to the other 10.
Exactly. It sounds like a dressed-up excuse for mass layoffs. So, does the source material actually back up this worker empowerment angle, or are we just looking at standard economic displacement?
Well, the fear of economic displacement is the central tension of any industrial automation, and your skepticism is totally warranted. We aren't here to take a side on the broader labor dispute, but we have to examine the engineering reality of why they chose teleoperation over AI for this specific type of heavy industrial work.
Okay, so what's the engineering logic?
It isn't just about PR. It's about the limitations of artificial intelligence when faced with tactile, highly chaotic environments. An AI model can easily be trained visually to recognize, a rusted pipe, a high-voltage wire, or a structural support beam.
Right, computer vision is great at that.
But what an AI cannot do is replicate 20 years of physical intuition.
You're talking about that gut feeling a veteran tradesperson has.
It is entirely about that gut feeling, which is really just an accumulation of thousands of micro-observations over a long career. A seasoned worker knows the exact sound a specific type of timber makes a split second before it splinters.
Oh, that makes sense. They feel the subtle, microscopic change in vibration when a drill bit transitions from hitting concrete to hitting a steel rebar inside that concrete.
Yes, and Satyress realized that human intuition is the most sophisticated software on the job site. The robot provides the indestructible muscle, but the human provides the irreplaceable tactical judgment.
But how does that intuition translate if the human is sitting in a trailer staring at a screen? If the operator isn't physically holding the drill, how do they feel that vibration?
Through haptic force feedback integration.
Haptics, like a video game controller vibrating.
Way more advanced than that.
Yeah.
The joysticks and control arms the operator uses physically push back against their hands. If the robot's chainsaw encounters a dense knot in a piece of wood, the sudden resistance is transmitted instantaneously to the operator's controls.
Oh, wow. So they actually feel the bind.
They do. They can adjust their angle intuitively, just as they would if they were physically holding the tool themselves.
So they're effectively transferring their physical expertise into this mechanical avatar. And to really grasp the human impact of that, the URBT news reports introduced this fascinating case study.
Yeah, the profile on Marcus.
Right. They profiled a veteran worker named Marcus who has spent over 2 decades as an industrial welder. He specializes in repairing the inside of massive pressurized chemical tanks, which is cramped, toxic, and incredibly hazardous.
And the physical toll of that environment is immense. The report highlights that Marcus's knees are just functionally destroyed from decades of crouching on metal grating.
Yeah, he's dealing with respiratory issues, chronic joint pain, and the constant underlying stress of working in a space where a minor leak can literally be fatal.
For Marcus, the hazards of manual labor are not theoretical data points. They are the painful reality of his everyday life.
So when the viral video of this terrifying mechanical demon drops online, Marcus doesn't have the same reaction the rest of the internet does. He isn't worried about a sci-fi dystopia.
No, he looks at the Satyress Threehalves and sees a lifeline.
He sees an opportunity to perform his highly specialized welding from a climate-controlled trailer 3 miles away from the toxic tank. The robot's joints take the wear and tear, and Marcus's knees finally get to rest.
And that perspective completely flips the narrative. When we zoom out from Marcus and examine the macro-level demographic data provided in the URBT reports, the urgency of this technology becomes really glaringly apparent.
What does the data show?
Statistically, Black, Latino, and lower-income employees are massively overrepresented in the most dangerous, physically punishing occupations in America.
We're talking about the crews who are deployed to climb utility poles in the middle of a Category 4 hurricane to restore power, the people digging miles underground in deep vein mines, or the hazmat teams physically hauling away toxic debris after a train derailment.
Exactly. And the socioeconomic reality for those workers means that a severe workplace injury is catastrophic. In many lower-income brackets, an accident on the job doesn't just mean a few weeks of paid medical leave and physical therapy.
Right. If a primary earner shatters a femur or suffers chemical bonds, it can trigger immediate financial ruin. It leads to eviction, insurmountable medical debt, and generational setbacks for their families.
It is a family-shattering disaster. So when you frame it like that, the idea of using teleoperation to physically remove a human being from a hazardous environment isn't just a cool tech upgrade.
No, it's a profound preservation of human life and economic stability. If you send a robot into a room with a ruptured gas line, you are entirely eliminating the risk of a widow or widower getting that horrible phone call. You are saving bodies.
The potential to reduce workplace fatalities in these high-risk sectors to near zero is honestly the most compelling argument for the rapid deployment of this technology.
But the Newsweek coverage in our source stack throws a massive bucket of cold water on that utopian vision. If the robot serves as the ultimate physical shield, it unfortunately opens up a trapdoor into a whole new set of legal and structural vulnerabilities for the working class.
Because teleoperation solves the physical danger, but it creates a legal minefield.
Exactly. Newsweek dug into the physical vulnerabilities of the Satyress Threehalves, specifically noting that the machine requires manual override procedures in the event of a catastrophic software or hardware failure.
Which is terrifying when you stop and visualize what that actually means on a job site.
Right. You have a 7-foot-tall heavy metal machine wielding live power tools on a crowded site. If the connection drops or the software glitches, someone has to physically walk up to this mechanical centaur and initiate a manual containment protocol.
And the presence of that manual override immediately introduces a massive chain of liability question. If you are the operator sitting safely in the air-conditioned trailer, manipulating those haptic joysticks, and the robot's arm suddenly jerks violently to the left and causes catastrophic structural damage to a building, who is legally responsible?
If a human swings a sledgehammer into the wrong wall, it is clearly human error. But if the robot does it, did the operator's hand slip, or did a microchip miscalculate the haptic feedback?
Or did the tech company push a flawed software update the night before? Labor advocates are screaming about this exact gray area.
They are pointing out that without rigorous, federally established standards, the worker holding the joystick is just the path of least resistance for blame.
It creates a tremendous power imbalance. A multi-billion-dollar robotics corporation has an army of defense attorneys and proprietary access to the machine's internal data logs.
So they can very easily argue that the machine functioned flawlessly and the accident was entirely the result of operator error.
And the working-class tradesperson does not have the resources or the data access to prove that the code glitched. They become an easy scapegoat for mechanical failures. Again, we're just imparting what the labor reports argue here, but the concern is very real.
And the inequality doesn't stop in the courtroom either. We established that this technology is a literal lifesaver for emergency responders and hazmat crews. But machines with haptic force feedback, heavy-duty actuators, and teleoperation interfaces carry a massive price tag.
Huge. The upfront capital expenditure required to integrate these platforms is immense. The fear outlined in the reports is the emergence of a two-tiered system of workplace safety.
Meaning wealthy, private corporations, massive energy conglomerates, private military contractors, top-tier construction firms will be able to afford fleets of these Satyress robots.
Right, they will deploy them to protect their privately contracted workers. Meanwhile, local, publicly funded municipalities are going to be left in the dust.
A small-town fire department or an underfunded city public works crew isn't going to have the budget for a mechanical centaur.
Exactly. When a toxic spill happens in a low-income municipality, they will be forced to send humans in hazardous material suits, taking on all the physical risk, simply because their local government couldn't afford the robotic shield.
The socioeconomic divide essentially determines who gets to operate a robot from a safe distance and who is forced to put their actual physical body on the line, which is it's a massive paradox.
We have a technology capable of ending physical suffering and manual labor, but it carries glaring legal traps for the workers and threatens to exacerbate municipal inequality.
So how do the people actually doing the work navigate this? The URBT news reports don't just highlight the doom and gloom, they detail the actionable, aggressive steps that labor organizers and worker advocates are taking right now to shape this rollout.
The most immediate push is for proactive training infrastructure. Unions and industry advocacy groups are realizing they cannot afford to be reactive here.
They're demanding that the transition to teleoperation prioritizes the existing workforce. Instead of tech companies bringing in, young, newly certified drone pilots or gamers to operate these heavy machines, the priority must be on upskilling veteran workers.
Which makes perfect engineering sense based on what we discussed earlier. You need Marcus.
Yeah.
You need the guy with 20 years of intuitive knowledge about how metal reacts to heat, even if his knees are shot.
He should absolutely be the first person in line for remote operator certification. But companies don't always do what is logical. They often do what is cheapest. So how do workers legally guarantee they aren't pushed out by cheaper, younger tech recruits?
By heavily lobbying for technology clauses to be woven directly into their collective bargaining agreements.
I found the concept of a technology clause absolutely fascinating. It acts as a preemptive legal shield. A union negotiates a contract that explicitly states if management introduces advanced robotics or teleoperation equipment to perform our scope of work, the company is legally obligated to train the current workforce to operate that new equipment.
It effectively blocks a corporation from using the arrival of a robot as a loophole to fire their legacy workforce. It forces the employer to view the machine as a tool for their employees rather than a replacement for them.
And to address the public sector funding gap we discussed, advocates are simultaneously pushing lawmakers to establish targeted federal grants, right?
Yes, these would be specific subsidies designed to ensure that lower-income municipalities and local emergency response teams have equal financial access to life-saving robotic platforms.
It's an attempt to level the playing field so that a public firefighter has the same robotic protections as a private corporate contractor. It really highlights that the future of this technology cannot be dictated solely by the engineers who build it or the executives who buy it.
No, if the working class is excluded from the deployment strategy, this machine just becomes an instrument of displacement and liability.
But if veteran workers have the legal frameworks to force their way to the table, the Satyress Threehalves actually fulfills its promise. It becomes a shield for their bodies and an evolution of their careers.
Engineering and sociology are inextricably linked here. The mechanics of the friction brakes are just as important as the mechanics of the union contracts.
If you are listening to this and you spend your day behind a desk completely removed from industrial construction or disaster response, it might be tempting to view this purely as an interesting tech development.
Right, like it doesn't affect you.
But the way our society decides to integrate automation, whether we weaponize it against the working class to cut costs or utilize it to elevate human safety, sets an ethical and legal precedent that will eventually bleed into every sector of the economy.
The legal frameworks established for a teleoperated centaur today will totally dictate how white-collar AI automation is handled tomorrow.
It forces a fundamental decision about how much we value the human element in an automated world. And as we wrap up, I want to leave you with one final thought that takes everything we've discussed and pushes it just a little bit further.
Oh, this is the really wild part to consider.
Yeah. So we talked extensively about Marcus. We pictured him sitting comfortably in a climate-controlled trailer on the job site, using haptic joysticks to operate a mechanical centaur deep inside a hazardous chemical tank. It's a massive victory for his physical safety.
But consider the underlying mechanics of teleoperation.
Right. If the human body is completely decoupled from the physical location of the labor, and all it requires is a secure internet connection and a control console, what dictates where that trailer actually has to be?
Nothing at all. The geography of it disappears.
Exactly. If heavy, blue-collar manual labor is suddenly transformed into a digital task performed on a screen, what is stopping massive corporations from applying the exact same outsourcing model they use for call centers and software development?
If a worker in another country can log into a secure server and operate a Satyress robot in a local American mine for a fraction of the hourly wage, the geographical boundaries of physical labor completely vanish.
Will the local tradesperson who thought they had finally secured their future in that air-conditioned trailer suddenly wake up to find themselves competing for a blue-collar construction job with the entire global workforce?
It's a sobering thought.
It really is. The terrifying reality might not be the mechanical demons stomping around the worksite. Well, rather, it might just be the invisible borderless screen controlling it.